This is our factoring review for pre-calculus for chapter 2. Just a quick review on how to factor. First of all, if we're going to factor a quadratic like this with the leading coefficient of 1, I'm just looking for a number pair that multiplies to 20 and adds up to 9. Those numbers are 4 and 5, so I use x plus 4 times x plus 5 to factor it. And the directions were to factor, so this is done. Next example. Now our leading coefficient isn't 1, and I have two choices. I could do a guess and check method. What are two terms that would multiply to 6x squared? I could have 6x and x, or potentially 3x and 2x. But because this isn't a prime number, I'm probably not going to do guess and check. Instead, I'll do the split middle term. And I could always do the split middle term, but sometimes if this is a prime number, I like to just go guess and check. So the split middle term, 6 times 8 is 48. And then I have to find two numbers that multiply to 48 and add to negative 19. So I'm thinking about the things that multiply to 48, and I came up with 3 and 16, which add to positive 19. So if I make both of them negative, then I have my winning pair. So then I'm going to split up this middle term. This negative 19x is equivalent to saying minus 3x and minus 16x. And then the plus 8 is the same. I could switch the order and have the negative 16x first. It doesn't matter. But then we're going to group. We're going to put those two together. We're going to put those two together. Look for GCF, or greatest common factor. I know that 3x goes into both of those. And if I take 3x out of both of them, then there's a 2x minus 1. And for the next two, I'm looking for a GCF. And I notice that 8 goes into both of them. But if I take an 8 out, it leaves me with a negative 2x plus 1, which isn't exactly the same as that one. So instead, I'm going to take out a negative 8. So if I factor a negative 8 out of both of those, that gives us 2x minus 1, which now is exactly the same as that one. So as far as the factoring goes, we'll take the common binomial, that's the 2x minus 1, times the factors that were out front, that's the 3x minus 8, and here it is factored. The next one is another factoring that I'm going to use grouping on. It is set up for grouping because it is it's a quadratic, or the polynomial, and it's a cubic, x cubed, x squared, x, and then the constant. So we're going to try to see if we can group it like this. There's no GCF that goes into all four terms. Instead, I'm going to look for a GCF in these first two, and I notice that 3x squared goes into both of them. And then a GCF in the last two terms would be 5, which goes into both of them. Then I know I did it correct if those two terms are exactly the same. So in factored form, it's going to be that common binomial, the x plus 4, times the factors in a binomial in our other part. This is the first time that the directions say to solve, so we're going to solve by factoring, and we're going to use a different type of factoring for this one even still. It is a quadratic, but there is no middle term of just an x. There's a leading coefficient that isn't equal to 1, but if you recall, there is a special kind of factoring called difference of squares. Both of these terms are perfect squares. It's a difference because of the minus sign. So the way we factor these is to take the square root of each one of those terms, and we're going to have a binomial with both of those square roots, except one of them will have a minus sign, the other one will have a plus sign. So this is now factored from the original, but since it said to solve and it's equal to 0, we're going to set each one of these individually equal to 0. Because if this first part equals 0, then that times whatever the second part is still going to be equal to 0. So I want to know what makes any one of these individually equal to 0. If I solve this one, we would get 4x equals 9, x equals 9/4. Solve the second one, subtract 9, divide by 4, and x equals negative 9/4. So we have two solutions for this one, and we had to solve to this point because there is an equal sign and it said to solve. Last one. So to solve it, and I'm going to try to factor it. This is a quadratic. Leading coefficient isn't 1, so I could try to use some guess and check, 2x and x. And I'm not thinking of anything that works, so then maybe I could try the split middle term. 2 times 1 is 2. What multiplies to 2 and adds to 5? can't think of anything. In fact, this one won't factor. So if you recall, we could use the quadratic formula on this one. X equals negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. So a little free there of earlier Algebra 1 skills. Inside of the square root, we call this the discriminant. 5 squared minus 4 times 2 times 1, that's 25 minus 8, which would be 17. Negative 5 plus or minus the square root of 17 all over 4. And if I had a calculator, and depending on the context, I could go to my calculator and get a couple of decimal answers. We'll say for the exact answer, we're just going to stop right there.